Hey everyone. Today we are going to dive into some equation solving, some pretty complex equation solving. And by this point in your mathematical career, I'm going to go ahead and assume that you know how to solve a basic like two-step equation. You've probably spent some time with equations where there's variables on both sides. You know the basics. So these examples that we're doing today really kind of go beyond the basics, and I want to show you some techniques and strategies that are a little bit different than maybe what you've seen in the past. So even if I'm doing a problem and you look at it and you go, that's not the way I would do it, I encourage you to go ahead and write down my method anyway, because you may find it helpful in the future. Okay. So for example, that very first one with all those fractions in it, I know that you all know how to work with fractions. I know that you could find a common denominator and turn them all into, something out of, I don't know, 30 or whatever it happens to be. But I want to show you a strategy, and I'm going to write this down so that you can refer to it later, called clearing the fractions. And the reason this strategy is important is when you get into some pretty complex equations where you've got variables all over the place, sometimes it's nice to be able to just get rid of that fraction element. Sometimes we want to make it so that things aren't fractions anymore. And so that's what this strategy does for us. It does kind of start the same way as if you were looking for a common denominator. So I'm going to look at the denominators here, which is the 6, the 5, and the 10, and ask myself, what's something that all three of those divide into? And the first thing I come up with is 30. Okay, all of these divide evenly into 30. So we could make this like something over 30 and something over 30 and something over 30. But instead of doing that, because my goal is to eliminate the fractions altogether, I'm going to take this entire equation and multiply it by 30. And I think you'll see what happens in just a minute. So when I say multiply by 30, I mean distribute to everything. I'm going to do 30 times 5 over 6. I'm going to do 30 times 3 over 5, and so on. I do want to show you how to type that into a calculator if you're not sure how. So when I go to do 30 times 5 over 6 in a calculator, I can just do 30 times 5 divided by 6. Okay? And that should come out to 25. Just so you know, if you're doing this in your head, you could also go 30 divided by 6 and then multiply by 5. So 30 divided by 6 is 5. 5 times 5 is 25. Either way, 30 times 5 over 6 gives us 25. And then 30 times 3 over 5 is going to be 18. So that becomes an 18x. And then I also have to remember to do this thing over here times the 30. So 30 times 11 over 10 should leave me with 33, and then that one has an x on it as well. And notice what happened here is I cleared the fractions by multiplying everything in the equation by 30, and now I'm left with this equation that looks a whole lot nicer, right? This is a whole lot nicer to work with than this thing with the big ugly fractions. So now from here, my next step would be to get my x's together on the same side. I've got x's on either side of the equals. So I'm going to subtract off this 18x. Okay. And I am left with 25 equals, let's see, 33 minus 18. Is that going to be 15? I believe so. Okay. And then to get rid of the 15 in front of the x, I'm going to divide both sides by 15. And 25 over 15, I could make that into a decimal if I wanted to. Mental math-wise, it's easier for me to make it into a reduced fraction. So 25 over 15 is 5/3. So I'm going to say x equals 5 over 3. All right. We're going to practice that clearing the fractions thing again on the next one. The next one, again, we could turn this into, something over 8. Or we could take this entire equation and multiply it by 8. Now, that's a little bit more confusing when you're trying to do 8 times x over 4. I want to show you what this would look like, but I will tell you that normally this next step that I'm about to write down, normally I wouldn't take the time to write that step out. It can be done mentally. So when I do 8 times x over 4, really what I end up with is 8 over 1 times x over 4, which if you just multiply straight across gives you 8x over 4. And then 8 divided by 4 gives me 2. So this piece right here, the 8 times x over 4, is really just going to leave me with a 2x. So let's try that with the next one without writing it down. So this would give me 8x over 2. 8 over 2 gives me 4. So 8 divided by 2 with an x there would give me 4x. The thing we have to be careful of here is this isn't a fraction here, but we still need to multiply it by the 8 to keep everything balanced. So I'm going to multiply this side by 8 also. And negative 15 times 8 is negative 120. Okay. This gives me 6x, and I can just put those two together because they're on the same side of the equal. So 6x equals negative 120. And then I'm going to divide by the 6 to get rid of it. And we're left with negative 20, I believe. Now, I should have done this on the last problem, but I'll do it on this one. Always good to check your answers when you're done. And when I say check, you don't necessarily have to write out how you're checking your answers. That can just be done in a calculator. So what I'm going to do is I'm going to put negative 20 in here for x. So I'm going to go negative 20 divided by 4 plus negative 20 divided by 2 and see if that comes out to equal negative 15. And it does, so that means that my answer is correct. Okay, this next problem I put in there for a couple of different reasons. The first reason is it uses decimals, and there actually is a strategy similar to clearing the fractions that you can use to clear decimals as well. I don't find this one to be as useful because we're comfortable with decimals for the most part when we use our calculator. So I'm not too worried about the decimals in there. They don't freak me out nearly as much as the fractions do. But there is some stuff with the negative signs in this problem that tend to throw people off. There's a question very similar to this on a quiz you're going to take. Okay, I'll just tell you that now. And I see a couple of very common mistakes that I want to make sure we address. So as I'm working through this problem, I've got some parentheses here. So I know that I'm going to need to distribute that thing that's out front, right? And it's very, very important that when you think of this 0.3, you include that negative sign with it. That's a negative 0.3 that's being distributed to the 20 and to the 2x. So if I were to rewrite this problem, I would end up with the 0.45x and then I'm going to do negative 0.3 times 20. And I end up with negative 6. So then this is going to end up being a minus 6. And then negative 0.3 times 2 should give me negative 0.6. Okay, make sure you've got that step down. Just be cautious here. Remember that problem I was mentioning on the quiz. One of the big mistakes I see is people want to make this a 0.03, and I really think that's just a careless error. That's just, something that people don't notice that it's a 0.3 and not a 0.03. So just be careful with those decimal places. Okay. All of this is together on the left side of the equation, which means anything that's like terms on this left side, I can go ahead and combine. And so what I'm going to combine here is the 0.45x with the negative 0.6x. But these are together on the same side of the equals. So I'm not going to do anything where I'm balancing it. I'm not going to add a 0.6 and add a 0.6 because I wouldn't want to add it twice on the same side of the equals. These are just together on the same side, and I'm just smashing them together. So I'm just doing 0.45 plus negative 0.6 or minus 0.6, okay? And so these two things put together should leave me with a negative 0.15. And that's still equal to negative 81. Okay. Now, when I start trying to move things over to this other side of the equal sign, when I'm trying to cross this wall that's right here, that's when I'm going to start adding things to the other side, okay? I don't do that here because these two are together on the same side and I'm just combining them. I'm not balancing. But this negative 6 here, I am going to balance it by adding a 6 to both sides. Okay. And so I end up with negative 0.15x equals negative 81 plus 6 is negative 75. And then divide by negative 0.15. And we end up with, 0.15, 500. And again, if I wanted to check that and make sure it's correct, I'm going to go, let's see, so you can see my equation here. 0.45 times 500 minus 0.3 times 20 plus 2 times 500. And my goal is for it to equal negative 81. Fingers crossed. Yes, it does equal negative 81. Okay, one more. This next one down here is going to involve the distributive property, and I'm going to do it on each side of the equation. So the very first thing I'm going to do is distribute this 4 here, and I'm going to distribute this 2 here. Okay, so I end up with 12x minus 8 equals 12x plus 10. Okay, so now we're looking at an equation that has x's on both sides. And I'm going to give you some advice here. It's not wrong if you do it a different way, because I think somewhere along the lines in junior high they teach you something different. But whenever I have an equation with x's on both sides, I always start by moving the x's around. One of the reasons I do that you're going to see here in just a second. And the other reason is then you have some control over how those x's turn out and which side of the equation they end up on. Are they going to be positive or negative? That kind of thing. So I don't start with the 8 and the 10. I start with the x's. So if I want to move this 12x over to this side, I would subtract it. Okay. And so here 12x minus 12x cancels, and here 12x minus 12x cancels. That is sort of a weird thing, okay? Normally when we're dealing with x's on both sides, we don't have them cancel on both sides. This is kind of going to be a unique case here, okay? So now what we're left with in our equation on this side is just a negative 8 and just a 10 over here. So think about this statement here. We just found that negative 8 has to be equivalent to 10. In what universe is that true? There is no universe where that's true, okay? This is a false statement, and we have no x's here, right? This thing where the x's both canceled out, that's what led to this situation. When this happens, we say there is no solution. And what that means is there's no possible value of x that I could plug in here that would make this equation true. There's no way to make these two things equal to each other. Now, I am going to throw one other thing at you here. Because sometimes this same thing happens and you end up with a statement like this, but it's a true statement. So let's say we had ended up with a negative 8 on both sides. Let's say that's what our final statement had turned out to be. That's always true, right? This is never true. Excuse me. This is always true. When it's always true, what we're going to say is infinitely many solutions. And you can abbreviate that IMS. And what that would mean in that situation is whatever equation you had started with, and it would have had to be a different equation than this one, it doesn't matter what you plug in for x. It'll always be true, okay? So when your x's both drop out on either side, you're going to be in one of these two situations, either no solution or every solution. Okay, so that's it for those 4 examples, and those kind of hit the key points that I wanted to talk about today. I'm going to go ahead and finish off today's lesson in a second video on the word problems that you'll find on the back of this note sheet. But if you're watching the video and working through the homework, if you wanted to take a minute now and go do some of the regular equations on your homework, you could, and then you could come back and watch the word problem video a little later.